In this video, we are going to learn about polynomials and their operations. First of all, we begin with the definition of a polynomial. A polynomial is an expression which has the form px, p for polynomial, equals an x to the power of n plus an minus 1 x to the power of n minus 1 to a1x, that is x to the power of 1, plus a0. So this expression is said to be a polynomial. Here n is always a positive integer. The an minus 1 to a0, these are called the coefficients of the polynomial. The highest power of this expression, which is n, so the highest power of x in this expression, which is n, is said to be the degree of the polynomial. So this is a polynomial of degree n, or it's a polynomial of order n. A polynomial that has only one term, something like this, 3x to the power of 2. This is said to be a monomial because it has only one term. A polynomial which has two terms, something like this, 4x to the power of 3 minus x. This is said to be a binomial. And a polynomial that has three terms, something like 3x to the power of 2 minus x plus 1, this is said to be a trinomial. So this one is a monomial, this one is a binomial, and this one is a trinomial. So the polynomial that you have the definition for here is a polynomial in only one variable. You can have polynomials in two or more variables. For example, you can have pxy equals 2x to the power of 3 y minus xy to the power of 2 plus y. So this is also a polynomial, but it has two variables, x and y. Okay. Another important concept that you need to know is like terms or similar terms. What are like terms? So a like terms are monomials that have the same variables and the corresponding variables have the same powers. What does this mean? For example, 3x to the power of 2 and 4x to the power of 2 are said to be like terms. Why? Because as you can see, they have the same variable x, and x has the same power 2. Yes, so the coefficient doesn't matter because you have x squared in both cases. These two monomials are like terms. Another example, negative xy squared and 5xy squared. These are also like terms because you have x and you have y squared. So the coefficient negative 1 here and 5 here doesn't matter. These two are still like terms. But for example, xy squared and x squared y, these are not like terms because here you have x, but here you have x squared. Here you have y squared, here you have y. So these are not like terms. So that's the meaning of like terms. Now, how do we add up polynomials? Okay, let me give you some examples. When you're adding up polynomials or you're subtracting polynomials, what you do is to add up the like terms. So you add up the coefficient of the like terms. For example, if I have 2x squared minus 3x plus 5, and I have another polynomial x squared plus 10x minus 2, and I want to add them up. Okay, here you can see that the parentheses are actually redundant because you're adding up these terms and it doesn't matter. So I can remove them. For example, I can say this equals 2x squared minus 3x plus 5 plus x squared plus 10x minus 2. Now I just look at the like term. So the highest power that I can see here is x squared. So I have 2x squared here and I have 1x squared here, so that gives me 3x squared. So I have 3x squared. Then the next highest power is just a power of 1. I have negative 3x here, I have 10x here. I add up the coefficients, negative 3 and 10, that gives me 7. So plus 7x. And finally I have the numbers 5 and negative 2. These are also like terms. I add them up. Negative 2 and 5 gives me plus 3. So that's how you add up two polynomials. Okay, let's see how we subtract them. Okay, if you have 5x squared minus x plus 3, and I have another trinomial 2x squared minus 7x plus 6, and I want to subtract them. Okay, so first the first thing you need to do here is to distribute this negative here. This negative does not affect only this term, it affects this one and this one as well. So you have to first distribute this negative, and this is how you do that. So the 5x squared minus x plus 3, and then you distribute this negative. Negative times 2x squared gives me negative 2x squared. Then the negative times negative 7 gives me plus 7 plus 7x. And then negative times 6 gives me negative 6. Then I just find the like terms and add them up. The highest power is x squared. I have 5x squared here. I have negative 2x squared here. 5 and negative 2, if you add them up, it is 3x squared. Then the next highest power is x, power 1. I have a negative 1x here. I have 7x here. Negative 1 and 7 is plus 6 plus 6x. And finally I have 3 and negative 6. If you add them up, it gives you negative 3. So that is about how you add up and subtract polynomials. Now, how do we multiply them? So imagine that a, b, and c are terms. So when I say term or monomial, I mean something like this: 3x squared, 5x, let's say 9xy. These are all monomials or terms. Now, assume that a, b, and c are terms, and I have a times b plus c. So this is how you multiply a and b plus c. You have to distribute this a, so you multiply a by b and you also multiply a by c. So it gives you ab plus ac. What if I have a plus b times c plus d, and here assume that a, b, c, and d are monomials like these here. So this is how I multiply. I have to multiply A by C and A by D, also B by C and B by D, and add them up. So it's AC plus AD plus BC plus BD. Okay, now let me give you some examples. Okay, imagine I have x squared plus 1, and I want to multiply that by 2x minus 7. So first I multiply x squared by 2x, and I get 2x to the power of 3. And then I multiply x squared by negative 7, I get negative 7x squared. And then I multiply 2 by 2x, 1 by 2x, I get plus 2x. And then I multiply 1 by negative 7, and I get negative 7. Okay, here I cannot simplify this because I don't see any like terms to add up. Okay, another example. X plus y, and I multiply that by x squared minus xy plus y squared. Okay, I need to first multiply x by x squared, that gives me x to the power of 3. X by negative xy gives me negative x squared y. X by y squared gives me plus x y squared. Then I begin multiplying y by every term in the second polynomial. So y by x squared gives me plus y x squared. Y by negative xy gives me negative xy squared, negative xy squared. And the last term gives me y squared gives me y to the power of 3. Now, as you can see here, I have a negative x squared y, and I have a positive x squared y. These are actually like terms because, as you can see, we have x squared and y to the power of 1. So you know that the order doesn't matter. So x squared y and y squared are like terms. So negative 1 x squared y and a positive 1 x squared y, they cancel each other. So this cancels this. For the same reason, these are like terms and they cancel out. So I am left with x to the power of 3 plus y to the power of 3. So x cubed plus y cubed. Okay, the last thing I want to cover is some special polynomials. These we're going to use a lot in the course, so you'd better memorize them. A plus b squared is a squared plus 2ab plus b squared. This is actually very easy to prove. The only thing you need to do is to use the basic definition of power. A plus b to the power of 2 is a plus b times a plus b. So you can multiply and you will see that it gives you this expression. And a minus b to the power of 2 is a squared minus 2ab plus b squared. A plus b times a minus b gives you a squared minus b squared. Another important one is a plus b times a squared minus ab plus b squared, which gives you a to the power of 3 plus b to the power of 3. So here you see an example of that. And the last one is a minus b times a squared plus ab plus b squared, which gives you a to the power of 3 minus b to the power of 3. Okay, these identities, identity means equation. These equations are going to be used a lot when we are factoring, so you'd better memorize them. Okay, and that's it for polynomials and their operations.